I'm your host, Leah Rosen, the online editor for Bioprocess International. Before we get started, just a couple of notes. This webcast is being recorded and will be made available for replay in the multimedia section of our website. We have muted the audio lines, but we welcome you to type in your questions for our speaker in the chat window on your screen. After the presentation, we will begin the question and answer portion, because this is, after all, Ask the Expert, and I will ask our speaker your questions from the chat window. Your questions in the chat window will only be visible to myself and our speaker. So thank you for joining us today. It is now my pleasure to introduce our speaker, Thomas Flouquet from Novasep.
Thank you. Hello everyone. So I will present to you today a simulation software which is called Biosc Predict, which is a software to maximize your chromatography steps, either for batch, parallel batch, or multi-column steps. By maximizing, I mean increasing your productivity or decreasing your cost of goods. For information, that software won the Arkema Innovation Award 2015. So just to place the context, is a simulation software, simulation and modelization software, which optimizes your capture step, your capture chromatography step. It works when you, as I said, for capture, not for isocratic mode, like, for example, gel filtration. With only a few data, in this case, breakthrough curves, it maximizes the utilization of the solvent to achieve users' objectives in terms of saving and productivity. So as already stated, cost of goods and productivity, saving solvent, saving buffer, and productivity. Not only this, it also sets up the parameters to program a Biosc unit. So it will simulate an optimized software and give you parameters to enter a Biosc unit, like the one you can see on the left, to run that optimized recipe. So the simulation process is done through 3 stages. The first one is my batch process. So here we will have to fill the software with information about what you are doing at the moment with your batch process. Okay, so here this is an example. We will go through a complete simulation. So in red, this is all the information you have to give to the software. In yellow, that will be all the information given by the software. So for example, you work at the moment with your batch process with a feed titer which is 1.3 grams per liter, with a column diameter at lab scale of 1.6 centimeter, your bed 8 is 20 centimeter, and you have the different steps of your process which are described just here. You have 1 load, 3 different washes, elution, equilibration, equilibration, and then the different velocities and numbers of BVs for all of those steps. So I just fill the software with information. Then the software is giving me what is the productivity of that batch process, just here. Whoa, that is big. 117 grams of product per liter of solvent within 24 hours. And this is also giving you the buffer consumption, 0.77 liters of buffer per gram of product purified. So this is the first step, just information about my batch process, so that later on we can have a fair comparison between your batch process and the optimized process that has been simulated. So then the second step is the modelization part. In that part, you will have to, as already stated, we need to enter breakthrough curves into the software to have your simulation, to get the simulation. At that stage, this is where we have to enter the breakthrough curves. I have to say to the software, the breakthrough curves were done with a feed of 1.4 grams per liter, with 1.6 centimeter diameter column and 10 centimeter bed 8. All the data collected during the breakthrough curves experiment can be entered into an Excel spreadsheet, and then you can directly import these data, and then once it is imported, you just have to modelize. So what will happen if we do that? So as you can see here, you have all the data from the breakthrough curves with different velocities, 3 different velocities in that case. And you have a drawing of your breakthrough curves. So one breakthrough curve at 150 centimeters per hour, another one to 300 centimeters per hour, and the last one at 450 centimeters per hour. The 3 breakthrough curves are complete because we aim to reach a saturation of the solvents when we want to optimize and when we want to use a multi-column chromatography step. So, and the software is also telling you what is the static binding capacity of your solvent with your feed. In that case, the maximum capacity of your solvent for your feed is 44.5 grams of product per liter of solvent. So that was the modelization part. Now let's switch to the simulation parts. So different stages. We'll go step by step. The first one, my Biosc parameter. Let's say you have a Biosc lab and you want to run a multi-column process. You plan to work once again at lab scale with 1.6 centimeter diameter column. Your static binding capacity is recovered from the modelization part. This is 44.5 grams per liter. The feed titer remain the same, 1.3 grams per liter, and you have a Biosc wash sequence, which is really specific to the Biosc. In that case, this is 100%. It means that the wash post-load, the wash one in this case, will be done in series. The loading will occur in series when you work with a multi-column chromatography kit. The wash after the load, in this case, will be also done in series. Then you have the optimization parameter. In the optimization parameter, I will enter a range of freedom for different optimization parameter. For the software, where the software will have to select in this range of freedom the optimized parameter. We have also recovered the, as you can see here, the process data from the batch, okay, with the different steps, the load, the different washes, the elution, regeneration, equilibration, with the velocities and the numbers of BVs. So if I enter optimization parameter, I said in this example, okay, the software is allowed to simulate an optimized recipe with 2 columns, 3, 4, 5, up to 6 columns. The bed 8 can range between 5 and 15 centimeter, loading velocity between 100 and 600 centimeter per hour, and the loading capacity should be between 58% of the maximum binding capacity, which is there, okay, 44.5, and 95% of 44.5. 58 stands for the batch capacity. Once this has been entered, I can click on Optimize, and what we will optimize is the loading step, as you can see there, okay? All the remaining steps, the washes, the elution, the regeneration, and the equilibration, will remain the same. We will keep the same nature of buffer and the same sequence of buffer. So here we have 150 centimeters per hour for the loading during 20 BVs. So by clicking on Optimize, now we switch to 450 centimeters per hour for 22.6 BVs. 22.6 BVs stand for 66% saturation of the solvent, so we are within the range. 29.4 grams per liter of solvent, of gram of product per liter of solvent. And the software is telling me, okay, according to the simulation, the optimized number of columns you should work with is 4. The bed 8 should be 5 centimeters. And you also have information about the period time and the cycle time. Something else, as you can see here, you have numbers that we call encol and enpush. These encol and enpush values are the value to enter into the Biosc unit to run that recipe. As you can see, there is 3 tabs, 1, 2, 3, just above. This is 3 different scenarios, depending on what are your objectives. Here, this is the time-saving scenario. This is to increase as much as possible your productivity. This is written maximize productivity, maximize median buffer saving, or balance between productivity and maximize median buffer saving. So if we go to the next tab, just there, as you can see, we will load a little bit more slowly compared. If we come back to the first one, we were at 450 for 22.6. Now we have 385 for 32.5 BVs, standing for 95% saturation, which is the maximum I have set, representing 42.3 grams per liter of sorbent. Once again, the optimized number of column is 4, the optimized bed height is 5 centimeters, and you still have information about the period and the cycle time. Then the last tab, which is the balance between both scenarios, 404 centimeters per hour, 29.7 numbers of PV, standing for 86.7% saturation, 38.6 grams per liter of sorbent. Once again, 4 columns of 5 centimeters bed height, and the information about the time, the cycle time, and the period time. As you can see, there is an economics part for every scenario. So just to show you, for every scenario that you will select, you have information about productivity and media saving. If we focus on that part, of course, every time information about the batch remain the same. This is coming from the information we enter during the first stage, my batch process. Regarding the Biosc sequence, you will have information about the productivity for the time-saving scenario. So 501 grams per liter of sorbent within 24 hours, 0.7 liter of buffer, roughly per gram of product. You have the productivity gain and the media savings. So you will have that for the time-saving scenario, for the sorbent-saving scenario, and for the balance scenario. Something else, the industrial scale production. So as I said, you are in development. In my example, you are working with a lab system. You know that at industrial scale, you will have to produce 5 kg within 12.8 hours. In that case, the software will tell you if you selected this scenario, the media saving scenario, it will tell you, okay, if you want to produce that amount in that amount of time, you will have to use 35 centimeter diameter column, 5 centimeter bed height, and the total volume of sorbent required will be 19.3 liters. Of course, if you increase that amount and if you reduce the time required, it will increase the diameter of the column and consequently the resin volume required. Something I would like to show also is that for every simulation that you run, you will have a report where you can recover every information that you have entered and that the software gives you. Let's go through a report. So this is a PDF format normally, but so just to go through what can be exported from this report, information about your batch process, the bed height, the diameter, okay, the feed titer, the steps of your batch process. We'll have also everything about the modelization when you have entered the Breakfa curve, the different data points, the figures of the Breakfa curves, how they were performed, and finally the simulation parts with how you plan to work with 1.6 centimeter diameter column, the feed titer, the optimization parameter that you have entered into the software, the Biosc sequence, how long will be the cycle, how much you want to load the column, and finally the sequence by itself, including the encode value and the push value that you have to enter into the Biosc kit. Then also you will have the information about the industrial scale production, what should be the scale up, the batch process economics parameter, and the same for the Biosc process. One specific case I would like to talk about is the parallel batch. Sometimes it is not always beneficial to work with multi-column process. So in that case, the software will tell you, okay, in that case, you should work with parallel batch or even batch. It is the same. So feed titer, here for the example, I have increased the feed titer up to 3 grams per liter. I have fixed the column length to 20 centimeter. For example, you plan to work with pre-packed column and you don't have any freedom about the bed height. and you can't go above 200 centimeters per hour, for example, for issue with the pressure. If I click on optimize, I will have this number appeaing there. If I click on it, I can see warning, this sequence is the parallel batch, but the optimization is finished. So this is two chronograms where we can compare parallel batch with SMCC. So here you have column 1 and column 2 for parallel batch, and here this is the time axis. Yeah. So we can see that when column 1 is in the loading zone, column 2 is processed. What do I mean by process? It means that it is washed, elute, regenerated, and equilibrated. When column 2 is in the loading zone, column 1 is processed. So there's only one column which is in the loading zone. There's no column in series in that case. For SMCC, column will be in series during the loading. This is what is allowing you to load more and to load faster. So here for SMCC, we have 1, 2, 3, 4 columns. When column 1 is in the loading zone, column 2 is in series with column 1. And for a part of the time, column 3 is in series with the column 1 and the column 2. During that time, column 4 is processed, so washed, elute, and regenerated. You will find this pattern for every column. For example, if we look at column 2 in the loading zone, column 3 in the loading zone, column 4 is also in the loading zone, and column 1 is in the loading zone. During that time, column 2 is processed. Just for you to understand what is the difference between parallel batch and SMCC. So as a conclusion, Biosc product generalizes the continuous chromatography. It capitalizes on batch chromatography knowledge. This is chromatography as you know it. So to design the most consistent continuous chromatography step to match the user expectation, you have to define first what are my objectives. Whatever capture step, it always was trying Biosc products. You can download for free the Biosc Predict Lite version on the link that you can see. And for further details, you can contact me directly. Thank you for your attention.
Thank you, Thomas. So go ahead and enter any questions you have in our chat window, and I will begin asking Thomas the questions. So the first question is, can Biosc Predict be used to develop continuous recipes with other equipment?
No, because the parameters that are coming from the simulation, the end-column and push value, are valid only for the Biosc unit.
And what is the difference between the light version and the non-light version?
On the light version, you have only one scenario available. You can't play with all the parameters compared to the non-light version, where you can. I was showing the non-light version.
Okay. And what is required to use Biosc Predict?
Only Breakfa curves. Breakfa curves, and you also need to know how you are performing your batch at the moment. What are your steps? What are the different steps required? So as I was showing, you need to know how many washes are required. Do you need a regeneration? Maybe you need an equilibration post-regeneration. You need to know that. You need to know your batch process first.
And is Biosc Predict able to design a process with 2 continuous steps?
You mean Biosc Predict?
Yes.
I did not hear you properly, sorry. Yes, it can. Because you can run 2 simulations, okay? So one for your first step, another one for your second step. And with the industrial scale prediction, you can size both systems so that both continuous systems can be designed with Biosc Predict. Am I clear?
Yes.
Is it clear? Or should I do it again? No, I'm clear. Okay.
No, that's clear. Is the chromatography model based on mass transfer limited or kinetics limited? And what are the model assumptions?
Well, during the modelization, the software defined the thermodynamics and the kinetics parameter of the solvent with your feed. So he knows, for example, if I was increasing much more the loading velocity, for example, up to 1,000 centimeters per hour, the software knows that it can't reach such a high speed because the breakthrough curves will be too not very steep. Do you see? Not very steep. So he knows that that won't be possible except if you put, for example, 15 columns in series. So it is taking into account thermodynamics and kinetics both.
Okay. And how long does it take to develop a Biosc Predict recipe?
I would say 1 month. If your batch process, I mean at lab scale, is already designed, you already have screened your solvent, you know what solvent you want to use, you know you already have defined different buffer you want to use. You require 1 month to develop the continuous chromatography step with Biosc Predict.
Very good. Well, thank you all for joining us. If there were any questions that you asked that didn't get answered, they will be passed on to our speaker. This presentation will be featured in the Ask the Expert section of Bioprocess International's October issue, and an on-demand version will be available for viewing on our website within this week. So look for an email that will alert you to that.
Okay, thank you.
Thank you all.